Okay. Alright, good.
Get out of here.
Okay.
I'm Art.
Alright, this is stuff we've done a little bit already, so this is going to be a little bit of review. So, it's the notes over circuits, I should say current, resistance, and voltage on the first slide. First thing, negative versus positive charges. What's wrong with this?
Should say electrons, not neutrons.
Should say electrons, not neutrons. And if you gain charge, what do you gain? Electrons or protons? No, electrons. And if something has gained electrons, is it positive or negative?
Negative.
Negative. And what is the unit for charge? Coulomb. What is the symbol for charge in the equations?
See?
Try again. Q. What's the symbol for coulombs? C. Okay. Electric potential is the same as volts behind me. Voltage. Thank you, Mike.
You're welcome.
All right.
Thank you, Mike.
Electric potential is voltage. Potential difference is also voltage. And later on, electromotive force will also be voltage as well. The main thing for circuits that you guys need to understand is that voltage provides the push for the electrons to move in a circuit. Does that make sense to everybody? So like when you hook up a 9-volt battery or something, that 9-volt battery is providing a push for the electrons to move. Alright, capacitors. Those are the two parallel plates that store electric energy. So you hook it up to a battery, one plate becomes positively charged, one plate becomes negatively charged. And we'll talk a little bit more of those in series and parallel when we get to that. Alright, flow of charge. Remember that it always flows from high potential energy to low potential energy. And although it's not what actually happens, we assume that positive charges are moving when we do circuits. You guys remember that? That is wrong. But you remember the story that they, at one time, just made a guess on which moved positive or negative, and they were wrong. So they never bothered to go back and change it. So we're going to assume that charge flows from positive to negative in a circuit, even though that's not what happens. Alright, current is the rate at which charge flows. More specifically, it'd be the rate at which electrons flow. And it's measured in coulombs of charge per second. So every second, how many coulombs go by as the current? Anybody remember what the unit for current is?
Amps.
Amps? What's that abbreviated with? And what's the symbol for current?
I.
So the symbol for current is I. Alright. And again, even though it's in the wrong direction, current points the way a positive charge would move. So it goes out of the positive end of the battery into the negative. Does everybody kind of understand that?
Sure.
So you'll get used to it as we go through it, but it is wrong. It's not what actually happens. The negative charge moves, the positive charge stays there. Alright, resistance. This is a measure of how hard it is for current to flow in a circuit. So the higher the resistance of something, the less current is going to flow through the circuit. Does that make sense to everybody? And a resistor is something that just blocks current from going through. It doesn't like absorb electrons or anything like that. It just blocks the current. Alright, Ohm's law. This is one of like 3 important equations for this. There aren't many equations for this section, but it's current, voltage, and resistance. So voltage V equals current I times resistance R. So again, if voltage is usually going to stay the same because it's usually going to be hooked up to like a 9-volt battery, a 20-volt battery, or something like that. So if the resistance goes up, the current goes down. And if the current goes up, the resistance goes down. Does everybody understand that? Alright. So circuits, for electricity to flow, you have to have a completed circuit. It has to go from the positive to the negative end of the battery and across something. So it has to go from the positive on one side of the light bulb, and the other side of the light bulb has to go to the negative. this is something that's going to be important as we do circuits. The symbols. A single cell is like one AA battery. We call that a single cell. Multiple AA batteries would be a battery. So, as far as I'm concerned, I'm going to refer to both of them as batteries, just because that's what you guys are used to the terminology as. I always forget to erase things, don't I? Right. Connecting wire is just a straight line. A resistor is going to be like an appliance or like a light bulb or something in the circuit, or it could actually be like a little resistor. That's a pointed squiggly line. The switch to open and the switch closed. You won't see many switches. The main thing you're going to see is resistors and batteries in the circuits we do. Alright, series and parallel circuits. Series circuit, there's only one path. Do you see how it has to go through each light bulb here? It doesn't have a choice. These over here, it can go through this light bulb, or this light bulb. It can't go through both. Like it can't go through this one and this one, like a single electron. The electron is going to go through one of those three. And a series circuit, if you remove one thing, everything goes out. Does that sound familiar from last when we talked about it before? Because now the connection's broken there, so nothing can get through. In a parallel circuit, if you take one out, everything else still lights up. So your house is wired in series or parallel? Parallel, remember what I said before, that if your houses were wired in series, if you unplugged one thing, everything would go out. Okay. Okay, so current in series versus parallel. So this would be like a series circuit when there has to go through each. This is a parallel circuit when it has a choice. If you add more things in parallel, does the total resistance go up or down, do you think? Down. So if you add another path, the total resistance goes down. What happens to the current? Goes up. So everybody that makes sense to everybody? If you add one in series, what happens to the total resistance? Goes up. Total resistance goes up if you add another one in series. And what happens to the total current in the circuit? Goes down. Does that make sense to everybody? Okay. For the math for resistors in series, if you have resistors in series, you're going to just add them up as you go. So like if you have two 6 ohm resistors in series, you add them together to get 12. Everybody understand that? This is something that's a little bit confusing. In a circuit, the voltage is always, like the total voltage in the circuit is always the voltage of the battery. So in this case, it's 12 volts. But the voltage gets lower as you go across each resistor. So as you go across this resistor, it drops 3 volts, so it goes from 12 here to 9 here. Does that make sense? This one it drops 7, so it goes from 9 here to 2 here. This one it drops 2, so it goes from 2 here to 0 here. And all those have to add up to 12, so it has to be at point A here it has to be 12, and at point H it has to be 0. Does that make sense to everybody? I know just because we're videotaping doesn't mean you guys can't ask questions. Because you're never this silent. Alright. Do you guys have any questions over that?
No.
Okay. Actually, I'm going to go back real quick. In a series circuit, like I said, the voltage drop across each one changes, but the current stays the same. So the current in this whole circuit is the same everywhere when they're in series. So in a series circuit, the voltage drops change, but the current stays the same everywhere. In a parallel circuit, the opposite happens. In a parallel circuit, the current changes in each branch. So the current in each branch adds up to the total current in the circuit. And the voltage is the same across each one. So if this was connected to, let's say, a 20 volt battery, the voltage across each branch would be 20 volts. So the voltage drop across this resistor would be 20, the voltage drop across this resistor would be 20, and the voltage drop across this resistor would be 20. Does that make sense? And we're going to go through a bunch of examples of all this to hopefully help you guys understand it better. Alright, Abby?
Sorry, for that last slide, why was it 20?
I just made up a number.
Oh, okay.
Alright. For resistance in parallel, there's a typo here. There should be 1 over REQ. And that REQ means equivalent resistance. You can all just read it as total resistance. So if there's 2 in parallel, you add up the reciprocals and then take the reciprocal of that. So if there's 4 and 4, you're going to do 1/4 plus 1/4, which is what?
A half.
A half. What's the reciprocal of 1/2? 2. So the total resistance is 2. Same thing here. It's 6 and 6. What's 1/6 plus 1/6? 1/3. What's reciprocal of 1/3? 3. If there were 3 6-ohm resistors, we do 1/6 plus 1/6 plus 1/6, and then take the reciprocal of that. You guys can understand that? And if they're identical resistors, you just divide by 2. But if they're not, you have to do the math. Okay. So this is kind of the summary of everything we just talked about. In a series circuit, the current is the same in every resistor. And that's the current that's equal to that in the battery. So the current coming out of the battery equals the current in each part. And the sum of the voltage drops adds up to the total voltage of the battery. So the voltage drops are different in a series circuit. The current is the same. In a parallel circuit, the voltage is the same. The current is different. Does that make sense to everybody? And the equivalent overall resistance, R total, is equal to R1 plus R2 plus R3 in series, and in parallel it's the reciprocal one. You guys have any questions over that? Okay. Combination. So you see how we have 2 in parallel here, and that's actually in series with the rest of this. So you see how it has to go through this one, it has to go through one of these two, and it has to go through this one. So this whole thing, and this are in series. But these two, it can go through this one, or it can go through that one. So those two are in parallel. Does everybody understand?
Can it go through both of them?
The current will go through both of them, but like for any individual electron, it's got to go through one or the other. Like one electron can't split and go through both. Does that make sense? Okay. So what we do is we do 1 over 4 plus 1 over 4, which is, what's the reciprocal of 1/2? 2. So we take that whole thing and replace it with just a 2 ohm resistor. Does that make sense to everybody? So now we just add this plus this plus this. What's our total resistance?
10.
10. So that would be RT equals 10 ohms. Okay. Alright. One thing I forgot to mention for those of you who are watching this via video is what's the unit for resistance? Ohms. And it's abbreviated, so
Omega.
ohm,
Horseshoe.
and it's abbreviated with a Greek letter of omega and horseshoe, if you want to call it that. Thank you, Kyle. Alright. And voltage is, unit for voltage is volt, abbreviated V. And current, I, is A for amps. Alright. So the two starter resistors here in series or parallel? Series. It has to go through both. Does that make sense? It can't go through one or the other. Alright, this next one, cross off this one, like scribble that out, and start that one. Are those two in series or parallel? Parallel. So see how it can go through, the current can go through that one, or it can go through that one.
Okay.
Alright, these two. Are these two in series or parallel? Series. If it goes through one, it has to go through the other. There's only one path through them. You guys understanding that?
Yeah.
Alright. Are these two in series or parallel? Parallel. If it goes through one, Or it can't go through both, it has to go through one or the other. These two, parallel. Again, it has a choice in which one it's going to go through. It's going to go through this one, or it's going to go through that one. Do you guys understand the series versus parallel thing?
Yeah.
Okay. Alright, so this is probably going to be a little confusing at first. We'll kind of get the hang of it as we go through some of them, though, I think. Alright, so if we have this circuit to this circuit, we're asking what happens to the total current in the circuit.
Goes down.
So what happens to the total resistance, first off? Increases, because we're adding one in series. Does that make sense to everybody?
Yeah.
So here the total resistance was 3, here it's 3 plus 4, so 7. So what happens to the current if the resistance goes up?
Goes down.
Goes down. So total current decreases. And what happens to the voltage drop across the 3 ohm resistor? Let me explain this one here. So in this case, when it's just one resistor, it drops from 6 to 0. From there to there. In this case, from here to here it drops from 6 to 0. Is it going to drop from 6 to 0 here? No. It's going to drop something less from 6 to something less, more than 0. So the voltage drop across here is not 6 anymore, it's something less than 6. We can figure it out mathematically, but that's, for now it's just something less than 6. Does that make sense to everybody? Kind of? Like I said, we're going to go through some more examples, and we can keep going through examples until you guys get this part. Alright, so the voltage drop across the 3 ohm resistor decreases in this one. Alright. Okay. In this one, we're adding one in parallel. So what happens to the total resistance of the circuit? Decreases. If we add another path, we're decreasing the total resistance. That's kind of how you want to think about it for these. If we add a resistor and it supplies like another path for the current to go through, you're decreasing the total resistance. And if you decrease the total resistance, what happens to the total current? Increases. Does that make sense to everybody? Why that increases?
Because we added the
Because we added another path, we added one in parallel. Alright, what happens to the voltage drop across the 3 ohm resistor? Alright, stays the same, because in a parallel circuit, each path has a voltage of whatever the battery is, in this case 10 volts. So the voltage drop across this one is 10, and the voltage drop across this one is 10. Does that make sense to everybody? This would be stays the same. Next one. Okay. This one's a little more complicated. The 6 ohm resistor. Is it adding another path?
No.
No. So what's it going to do to the total resistance? Increase. If it doesn't add another path and we add it, it's going to increase the total resistance. Does that make sense to everybody? Sorry, you look confused.
I am confused.
Okay. So if we look at the last one, did you see I had this 4 when we added it? It can either go through this one or it can go through this one. So we added another path.
Right.
In this one, we had
Oh, it
2
didn't
paths
add
to begin
another
with.
path.
We still have 2 paths to end with.
Okay. Okay.
So it's going to increase the total resistance in the circuit. Does that make sense? Because now this is still 5, this top part's going to be 9. So less current's going to get through this top part. So the total current in the circuit is going to be less.
Okay.
Does everybody understand that? Okay. So the overall resistance of this increased because this top part went from 3 to 9. Does that make sense? So less current's going to be coming through here, and that means there's going to be less current total in the circuit. Sean?
I get that part, but I'm confused as to like what like like what the resistance does with the voltage. Like I don't understand why it goes.
Okay, the overall voltage in the circuit stays the same.
Yes.
But if you add more in series, the voltage drop goes down. Okay, let me explain this one from the beginning again. Okay. Let's start over again with this one. So we start with 20 volts here.
Yep.
So we have 20 volts going across this one, 20 volts going across this one. Make sense? Over here, we still have 20 volts across this one and 20 volts across this one. Does that part make sense?
Yeah.
Okay. In this one, we're going to have some current flowing through here and some current flowing through there, based on like what those resistors are. In this one, the same amount of current is going to flow through here because this one hasn't changed. But now this one, the resistance has gone up. So what's going to happen to the current in that one?
It's going to decrease.
It's going to decrease. So if it stays the same in this one and decreases in this one, what happens to the total current in the circuit?
Yes.
It stays the same.
Decreases. So if this one stayed the same and this one decreased, what happened to the total?
Oh, because
Yep, does that make sense?
But when it says what happens to the current in the circuit, does
That
it,
means like coming there, going in there and out there and in there.
but how would it change depending on the resistance? Is it the same amount of voltage every time?
It's the same amount of voltage that's going through both branches, but if the resistance goes up in any circuit, the current goes down
Okay.
because V equals IR. So V stays the same, resistance goes up, current goes down.
Okay.
Alright, so what happens to the current in the circuit, everybody? Decreases. Alright, next one. What happens to the voltage drop in the 3 ohm resistor? Decreases because it's 20 volts from here to here, just like it was 20 volts from there to there before. In this one, the voltage drop is 20. In this one, the total voltage drop from here to here is going to be 20. From here to here, it's going to be something less than 20. Because part of it's going to drop across the 3, part of it's going to drop across the 6. Does that make sense to everybody?
Yes.
Okay. So that would be decreases as well. Alright. Next one. What happens to the current in the circuit? Okay, are we adding another path or not adding another path? Add another path, so what happens to the current? Increases. The total resistance goes down because we added another path. The current in the circuit then goes up. How are you guys doing?
I would like to notice.
How's this one different from the last one?
What?
Because we added another
Last one?
resistor.
Okay.
Yeah.
In this, in this one, did we add another path? Do you see how there's two paths to
okay,
begin
that's
with?
what you're right.
In this one, now we had one path, and now we have
there's
two.
Right.
Okay.
Never mind.
Resistance, got it?
Wait,
Okay.
wait, it's me.
Okay. Shh, guys, quiet. In this case, we added another path, so the resistance went down. Does that make sense?
Wouldn't it go up if there's another path?
Okay. If we, so now, like, we can add one through here, it can go through here, or I can go through here. So, you can still do what it did before, but now it can also do this, so more total is going to get through, so that means there's less resistance. Does that make sense? And in terms of current, it might be easier to think about in terms of current. The same amount of current is going to get through here, but now an additional current is going to go through here, so the total current in the circuit is going to be more. Does that make sense? Okay. And what happens to the voltage drop across the 3 ohm resistor? This one's kind of tricky. Okay, voltage drop. Alright, so before this dropped some here, and dropped some here. It dropped more here because this resistance is bigger. Does that make sense? And those two drops would add up to 20. Now, from here to here, did the voltage or did the resistance get bigger or smaller? Smaller. Resistance got smaller from here to here, so what happens to the voltage drop?
Bigger.
Decreases. The bigger the resistance, the bigger the voltage drop. So again, it dropped more across the 6 before than it did across the 3. Does that make sense to everybody? Now, the 6 got, this part over here with the 6 in it got smaller for resistance, so the voltage drop got smaller. So what happens to the voltage drop across this one?
It gets smaller.
Bigger, increases. So they have to add to 20, and whether they get, like, how big they are is a proportion. So if one gets smaller, the other has to go up to compensate for it.
Describe that one more time.
Okay, this one is. Okay. Let me try this again. Okay. So, everybody understand how from these two, from here to here, the resistance gets smaller. So like there and there. Over here, the resistance overall is smaller because we've added another path, and it always decreases the resistance.
Decreases the resistance, but it increases
Increases the current. Yep.
Is there more ways for the current to flow?
So there's more ways for the current to flow. So now we decrease the resistance. I'm just going to mark these from here to here. When you decrease the resistance, you decrease the voltage drop across that one. So now, let's say, I'm going to make up a number. Let's say across this one it was 10, or it was 12 before. And now from here to here it's 10. Does that make sense? Because the resistance went down. So they all have to add to 20 still. So if it was 12, this one was 8. Does that make sense? Now if it's gone down to 10, this one has to be 10. So it increased. Does that make sense, you guys?
So as one decreases, you have to increase the other.
Yep.
And then what's
Not a sport.
It's getting there.
It's getting there.
Is there a voltage drop on the 7 and 10?
There is a
Really,
voltage
I
drop
just
across
think-
the 7.
But you're not adding it.
In that adding up the 20.
No. The adding up to 20 is like both of them. Yeah.
So it's, you only include one of the paths. When you're
You
adding.
only include one of the paths. Well, you only want, we'll include both later on, but you only want to think about when we're doing this. Okay. How many more do we have to do here? 2 more. Alright. Let's get through this one here real quick. And then we'll stop. Alright. What happens to the current and voltage in this one? What happens to the current from point A to point B? What happens to the resistance from point A to point B?
Decreases so the current
Increases, there's more room for
the resistance.
Wait.
Resistance increases from A to B.
So they're
It was 3, now it's 10.
God.
Abby, does that make sense? So
So,
from A to B,
Oh.
it was 3, now it's 10.
Not another path.
There's not another path.
That's what we're just
Okay.
Okay,
so it decreases.
so it decreases.
So the current increases, but the resistance increases.
Yep. And what happens to the voltage drop in the 3-ohm resistor?
It goes decreases.
It decreases. Let me explain why. Alright. So it was, in this path it was 20. It's 20 from A to B still, but now it's going to be something less than 20 just across the 3.
Because it has to share.
Because it has to share with the 7. You can think about it in